Hi, it's Bill Hitchcock, and it's Friday, March 20th, 2020, and we're wrapping up our third series of financial functions in Excel. This one uses net present value analysis, and with net present value analysis, what we do is typically we're looking at making an investment. So I've got some cash flows. Here I typed in negative $100,000 minus 100, 1, 2, 3. To show you that we're making the investment. Say we're going to buy a piece of machinery, and then from that we hope to get cash flows into the future. So I'm assuming that once I start operating my piece of machinery, I'll get a net cash flow of $30,000 in the first year, another $30,000, another $30,000, and so on. So what I can do is sum up those cash flows. And that gives me $20,000. I could also add in here an extra column. So let's just right click on column E and insert something. And what I'll do is I'll take my cash flow field name and I'll put in front of the word cash flow the cumulative cash flow. So in this case for year 0, in other words right now it's just equal to my negative cash flow, and then I'll add the negative cash flow plus all my positive cash flows. So I'm still $70,000 in the hole. If we copy this down, at the end you can see I don't actually pay back my machine until I'm in year 4. So it's in between here. It's actually the $20,000 divided by my cash flow here, so you can find out what part of the year. I'm sorry, it'd be the $10,000 divided by the $30,000. So we'd actually have payback after 3 years and a third. So for the discount factors, it's kind of similar to what we did with our present value and future value tables. We're going to do equals 1 divided by parenthesis 1 plus my discount rate. So I'll hit function F4 a couple of times. And I want to raise that to the year power. So in this case it's 0. So 1 plus 6% raised to the 0 power. Any number raised to the 0 power is always equal to 1. 1 divided by 1 is 1. My discount factor will be 1. $1 today is worth $1. I'm going to adjust my font size here, make that look to be the same, font size 10. I'm going to format this discount factor, and let's add maybe a couple of extra decimal points. So $1 1 year from now at 6% is really only worth 94% of that, 94.34. 2 years from now, $1 is only worth 89%, and we can carry that down. So for my discounted cash flow, it's equal to $100,000 times my discount factor. Let's use the same formatting that we had here. I'm going to choose my format painter. Copy that down. And then here I've got my sum formula. So I want to sum up the discounted cash flows. And it tells me that I have a total discounted cash flows of $3,953. So don't think that that's what you're going to have kind of at the end. It's not like what you're going to have in your cash book at the end. It's just telling you on relative terms, this is what the net present value would be if we have a discount rate of 6%. So if that net present value is greater than 0, it says, hey, you know what? Take this investment on. If you hope to earn 6%, you'll earn that and more. So up at the top, I've got my net present value. I want to do a calculation to find out exactly what that number is. So there is a NPV function, and we take the rate, and I put in my cash flows. So if I highlight the cash flows and hit enter, we get a somewhat different number, 3,729. So the problem is it's all about the timing of the cash flows, if it's happened at the beginning of the year, if it's happened at the end of the year, and so on. So what I need to do with my net present value to make this more accurate is I'm going to take and use the cash flow here and add to it the net present value of my year one. Oops, hang on, I messed that up. Let me try this again. Equals the cash flow in year 0, in other words right now, plus the net present value of this interest rate, comma, and my values, or my cash flows, are going to be the ones in year 1 through year 4, or if you include this last one, it won't hurt anything. Type in a parenthesis and enter, and there I get my $3,953, which matches up what we got with our discounted cash flows here. So you've got to just change this slightly to reflect that value a little bit better. All right, that's the first part. Second thing is we set our discount rate. We want to set this to find out where exactly, how much are we going to be earning with our net present value to get this exactly to 0. So I can do that a few different ways. I can use data, what if analysis, choose goal seek. I want to set the net present value to 0 by changing my discount rate. I'll hit OK. It crunches through some numbers, returns a value 7.7%. I'll hit OK. And if you look up here on the formula bar, it actually carries this out 7.7138. And I could have done that by just guessing numbers and see as my net present value gets closer and closer to 0. Another way of doing it is to use something that's called the internal rate of return. So I can type in equals IRR, parenthesis, my values are the cash flows, and then it asks for a guess. Usually I would just guess 0.1. It's got to have a place to start doing that what if type analysis. So 0.1, 10%, we'll put in that, hit enter, and sure enough, it returns 7.71%, the same as what we had over here. All right, finally what I want to do is I want to set up a table where I've got some discount factors and find out what happens if I start changing this number. In other words, what if I didn't have a discount rate? I make it 0. And there I see that my discounted cash flow and net present value is worth the $20,000. All these cash flows are the same. They're in today's dollars. That's what we get. Or I could try 1%. I could try 2%. I could try 3%. And so on. And you can see as I'm doing that, the net present value starts going down because we're requiring a higher rate of interest. So for my discount factor, let's put in 0%. Let's add the previous cell plus 1%. And we'll copy that down. Let's take it all the way up. Just 10% is fine. I'm going to format those so they all just have no decimal point. So we've got that in there. Let's save this. And now if I want to set this up as a data table, I'm going to need to take these. I want to copy them, put it one cell below it. And for the very first one, I want to reference whatever I've got up here in the discount rate. Hit enter. For the net present value, I've got to reference my net present value here, or I could also do it down here with the discounted cash flow. It would work there just as well. Hit enter. There I've got my 11,513. Let's save this work in case I mess things up. Highlight my table. Go to Data. Choose What If Analysis. Choose a data table. I'm going to choose the column input cell. The column input cell is this discount rate. So it's going to substitute in 0% into there, 1% into there, 2% into there, and so on, and compute the net present value. Hit OK. Take my cell here. Let's use the Format Painter and format paint all these numbers. And there we go. So when it was at 0%, indeed we found we had $20,000. Here you can see where it's changing between a positive number and a negative number. That's because that's what our internal rate of return was, the 7.7%. And you can see what happens with our net present value. So we're almost done. Last thing is, we'll save this one more time. We'll try just changing a few things in our cash flows just to see what happens. Oh, sorry. I'm trying to save this. There we go. So for instance, what if we actually get our cash flow a little bit earlier? Say that, or actually a little bit later. See, in the first year, we have some troubles with the new machine. We had to go through some extra training costs, get somebody else to come in, some consultant to come in and help us get everything working. We only get $20,000 in net cash flow the first year, but then at the end of it, we finally figure things out and it's working really well. So that way, my total stays the same, but notice when the timing of my cash flows changes, my internal rate of return has gone down. The net present value has actually gone down a little bit. And, so timing of cash flow makes a big difference. Flip side, if for some reason we did really well the first year, but by the end of the year, the machine starts kind of wearing down and we have to fix it a bit more. So I earn more at the beginning versus the end. Here my totals are keeping those the same. And when that happens, my net present value actually shot up. My internal rate of return shoots up. Again, it's all because you want money sooner rather than later. So that gives us a quick lesson about we had the present value and the future value. Now in this one, we've got the net present value and working with some financial formulas. Give it a try. Make sure you can work all this stuff out and experiment with the numbers, see what happens when you change our inputs. You should be good.